Confirming inequality solutions. I'll demonstrate that with an example. An example that we just solved in the previous video. It was this inequality, and I found this graph solution. Now there was a method. Let's go back and look at this method. This method was outlined here, and it had two steps. One, apply PEMDAS to the left and to the right, and then apply properties of the inequality, sometimes properties of the equality too, if it's greater than or equal or less than or equal. And in this case, when we confirm solutions of inequalities, we're only going to have the first major step, meaning PEMDAS to the left and PEMDAS to the right. We're not going to apply properties of the equality because there's not going to be any unknown to isolate, and all the terms are going to be constant terms. We're not going to have to cross the bridge. Okay, so the method for confirming inequality solutions is just PEMDAS. Same way that when we were confirming equality solutions, it was just PEMDAS. So what do I do here? First of all, I'm gonna look at the solutions that I have found. The best version of the solution is the graph solution. That gives me where the solutions are. In particular, in this example, the solutions are here in this area, and as we can see are less than -2, but we can also be at -2. To confirm our solutions, I need to pick a number from this area, plug it in, and see if I will get a true statement. Then I will pick a number from this area, plug it in, and see that I will get a false statement. So in the second case, when the number is from the false area, I should find a false statement, and that would be a good thing. Okay, now which number should I choose? Usually I choose the simplest number. The simplest number in this area is probably -3, which is somewhere here, and the simplest number from that area is probably 0. So there are many other options. I just choose. You can just choose whatever number is more convenient to you, or whatever number comes first to mind. Okay, so I will choose -3. So I will plug in x equals -3, and I expect to find a true statement. Let's do that. Now, how do I plug in -3? Wherever is x, it will be replaced with parenthesis -3. Okay, so let's start with the left hand side. 3 drops, negative drops, 2 drops, parenthesis, drops. I will make it a little bigger because I will have another parenthesis inside of it. 4 drops, x will be replaced by parenthesis -3. If you don't put a parenthesis, you may get it confused, and instead of multiplying times -3, you may actually subtract 3. So always put a parenthesis. Negative drops, 2 drops, parenthesis, drops, and that's the bigger parenthesis. Greater than or equal to, drops, 11 drops, plus drops, 4 drops, parenthesis, drops, negative drops, x becomes parenthesis negative 3, plus drops, 1 drops, parenthesis, drops as a bigger parenthesis. And this is what I got. Now I will do PEMDAS to the left and PEMDAS to the right. How do I do that? Let's write PEMDAS and let it guide me. Do I have parentheses? Yes. Let's put a PEMDAS inside the parentheses and let it guide me. Do I have parentheses inside this parenthesis? Yes. Is there anything to do inside this parenthesis? No. So parenthesis doesn't apply. Do I have exponent inside this parenthesis? No exponents. Do I have a multiplication inside this parenthesis? Yes, it's here. So this is what I'm gonna do first. That means I have something to do inside this parenthesis, and what I do now is the P of the external PEMDAS that governs the entire left hand side. So what I'm doing now is M in this little PEMDAS. Okay, let's do that. Everything else will drop. 3 drops, negative drops, 2 is outside the parenthesis, so it's gonna drop, parenthesis, drops, and here is the multiplication. I need to multiply 4, which is positive 4 times negative 3. Okay, it's a positive times a negative. I'll get a negative 4 times 3. I get 12. This negative drops, 2 drops, parenthesis, drops. And that's what happens to the left. The inequality symbol is not gonna flip no matter what. That happens only when we apply properties of the inequality, and that's only when we cross the bridge or isolate. Here I'm just gonna do PEMDAS, and that symbol remains, and the equality too. Alright, now let's see what I'm gonna do on the right. I will let PEMDAS guide me. So let's write a PEMDAS here. This PEMDAS is going to govern the entire right hand side. Let's start with the P. Do I have a parenthesis? Yes. Okay, well, obviously there is stuff going on here, but let's double check. Let's put a little PEMDAS there. That little PEMDAS is gonna govern only what's inside this parenthesis. Do I have parentheses inside this parenthesis? Yes, but there's nothing to do, just one number, nothing else. So no parenthesis inside the parenthesis applies. Exponents? No. Multiplication? Well, it's a hidden multiplication. It's actually negative 1 times negative 3. And this is what I will do. I will do the multiplication. And let's emphasize it. When I have negative this parenthesis, I actually have negative 1 times this parenthesis. It's just not written because the 1 doesn't change anything. So since I have something to do inside the parenthesis, I apply P from the PEMDAS that governs the entire side. So the only thing that will change is the multiplication inside this parenthesis. Everything else drops. Okay, let's start writing. 11 drops, plus drops, 4 drops, parenthesis drops, and then we have negative 1 times negative 3. Okay, what's negative times a negative? It's a positive. Sometimes we don't write it. 1 times 3 is 3. So I don't need to write plus 3, but if I write 3, it's implied it's positive 3. Plus drops, 1 drops, and the parenthesis drops. And that's how I get the first line. Now I do have a new line. I'm going to start with a new PEMDAS to the left and a new PEMDAS to the right. Let's start with the PEMDAS to the left that governs the left hand side. Do I have a parenthesis? Yes. Let's see if there is anything to do inside this parenthesis. This is the parenthesis. Let's see if there is anything to do. I put a PEMDAS. Do I have a parenthesis inside the parenthesis? No. Exponents? No. Multiplication? No. Division? No. Addition, subtraction? Yes. Okay, I can add or subtract negative 12 and negative 2, and this is what I'm gonna do. That means I have something to do inside the parenthesis, and I'm still on the P letter of the outside PEMDAS, but on the AS letter on the inside the parenthesis PEMDAS. Okay, let's do that. I can emphasize that this is what I'm adding, the negative 12 and the 12. Alright, everything else drops. 3 drops, negative drops, 2 drops, the parenthesis drops, negative 12, negative 2. How do I do that? Well, they have the same sign, they're both negative, so I add them. 12 plus 2 is 14. Negative, they're both negative, so that's a negative 14, and the parenthesis closes. Okay, the sign, the symbol drops, the inequality symbol and the equality symbol drops, and I'm gonna look what happens on the right hand side. Let's write down PEMDAS to help me. Okay, do I have a parenthesis on the right? Yes, that's the parenthesis. Let's see if there is anything to do inside this parenthesis. So let's put a little PEMDAS inside the parenthesis. Inside the parenthesis, do I have a P? No. An E? No. An M? No. Division? No. Addition, subtraction? Yes. Those are like terms. I can add them or subtract them. So what I'm going to do is the addition or subtraction. Therefore, in the external PEMDAS, I am still at P. I'm working inside the parenthesis by adding and subtracting terms. Let's do that. 11 is not inside the parenthesis, drops. Plus is not inside the parenthesis, drops. 4 is not inside the parenthesis, drops. 3 plus 1, 4. I will put it inside the parenthesis. If I don't put it inside the parenthesis, I have to put the multiplication symbol. I will just put it inside the parenthesis in case I forget to put the symbol and I just write 4 and then think that this is 44. So the best thing is let's just put it in a parenthesis. Okay, and I have a new line. In order to continue, I need to do a new PEMDAS on the left. Let's see, do I have a parenthesis? Yes, but there is nothing to do in there, it's just a number, so no parenthesis anymore, meaning we're done with the P. Exponents, no. Multiplication, yes, it's 2 times negative 2 times negative 14, so I'm doing the multiplication, and let's do it. Everything else drops. The only thing that will change is this multiplication. That includes the negative 2, that's the negative sign, so it's negative 2 times negative 14. So 3 drops. Now negative 2 times negative 14, let's start with the signs. Negative times a negative, positive. 2 times 14, 28. Done with the right hand side. The inequality and equality symbols drop. Let's see what happens here. I will do a PEMDAS to let it guide me. Do I have a parenthesis on the right? Yes. Is there anything to do inside this parenthesis? No. It's just a single number, nothing to do. So no P. Exponents? No. Multiplications? Yes. It's plus 4 times a 4. And this is what I do. Common mistake is to, instead of multiplying 4 times 4, to add 11 plus 4 first, for example. That would be a mistake. So I'll do the multiplication, everything else drop, in particular 11 is going to drop. Now, plus 4 times a 4. This 4 is also positive, so you have positive times a positive. You get plus 4 times 4, 16. I use a new PEMDAS to the left and a new PEMDAS to the right. Let's start with the left hand side. Do I have a parenthesis on the left? No. Exponents? No. Multiplication? No. Division? No. Addition, subtraction? Yes. Are they like terms? Yes. I can do addition, subtraction, and this is how I'll proceed on the left hand side. Okay, so 3 plus 28, that is 31. The equality symbols drop, and let's go to the right hand side. I let PEMDAS guide me. Do I have a parenthesis? No. Exponent? No. Multiplication? No. Division? No. Addition, subtraction? Yes. Are they like terms? Yes. So I will just do addition, subtraction on the right. Okay, so on the right I will add those two the same way that on the left I added those two. Okay, what do I get now? 11 plus 16, they're both positive, so I get a positive. 11 plus 16 is 27. And this is what I get: 31 greater than or equal to 27. Now, let's see what I expect. I expect that when I plug in -3, I will come to a true statement. Is this a true statement? Well, let's see what that tells me. That tells me that 31 is greater than or equal to 27. So there is an or there, and in mathematical symbols I can write it as 31 greater than 27 or 31 equal to 27. Now, when it comes to the mathematical or, the statement is true if at least one of the parts that relates are true. If at least one of them is true, then the whole thing is considered as a true statement. If none of them is true, then it's considered as a false statement. Now, as we look at this one, obviously 31 is not equal to 27. That's false. And we start worrying what's going on. But when we look at this one, this is true. So because one of them is true, the whole thing is considered as true. That's that's what or, the mathematical or, means. So if we look at the conclusion, the inequality is true, the equality is false, but the whole thing, because at least one of them is true, is true. And this is what I expected to find. So that's good. Now, I will plug in one more number from the false area, and I will expect to get a false statement. Let's do it at the bottom. So I will do it here, and what would that number be? Any number in that false area is good. What is the any number? Any numbers that's greater than -2. A number, such a number is -1, 0, 0.1, 0.2. Whichever part has the 0, choose the 0 as representative of this part, because it's such a simple number. So I'm going to choose 0, and I will expect to get a false statement. How do I do that? X would be replaced by 0. So I will rewrite that example, but I will replace x by 0. So 3 minus 2, parenthesis 4 times 0 minus 2. Just rewrote the left hand side. The inequality and inequality remains as is. Now for the right hand side, 11 plus 4, parenthesis -0 plus 1. 0 is kind of easy. Now how do I proceed? It's the same method as the previous that we use for inequalities, but it's just PEMDAS. I don't have to cross the bridge or isolate because there's no unknown. In other words, I'm not going to have to use properties of the equalities like adding or subtracting from both sides, or multiplying both sides, or dividing both sides. Just doing PEMDAS and see what comes out. So let's do PEMDAS. And I refer to the left hand side, PEMDAS to the left first. Do I have a parenthesis? Yes. Let's see if there is anything to be done inside the parenthesis. So let's put a little PEMDAS inside the parenthesis. Do I have a parenthesis inside the parenthesis? No. Exponents? No. Multiplication? Yes. So I'm doing the multiplication inside the parenthesis, and outside the parenthesis on the left hand side I'm doing the P. Okay, let's see what happens. Everything that's not M inside the parenthesis drop, meaning everything that's not 4 times 0 drops. So 3 drops, minus 2, parenthesis drops. 4 times 0 is 0. Anything times 0 is 0. Minus 2 drops, parenthesis. Symbols drop. Now let's see what I'm doing here. I need another PEMDAS. Do I have a parenthesis? Yes. Let's go inside the parenthesis and see if there is anything to do. I'm going to put a little PEMDAS inside the parenthesis. Do I have a parenthesis inside the parenthesis? No. Exponents? No. Multiplication? No. Division? No. Addition, subtraction? Yes. Okay, I do the addition, subtraction. That means I'm on the P letter on the PEMDAS that governs the right hand side. Everything that's not addition, subtraction inside the parenthesis dropped. So let's see what happens. 11 is going to drop, plus drops, 4 drops, times drops. I'll put a parenthesis just to in case I forgot to put the times. Let's put a parenthesis. What's -0 plus 1? Well, -0 is just 0, plus 1 is plus 1, and I'm just going to write 1. Okay. Now let's go to the left hand side and do a new PEMDAS. Do I have a parenthesis on the left? Yes. Is there anything to do? Let's find out. Let's do a little PEMDAS. Do I have a parenthesis inside the parenthesis? No exponents, no multiplication, no division, no addition, subtraction. Yes, it's 0 minus 2. So I have to do addition, subtraction. Therefore, I'm still on the letter P. Everything drops other than addition, subtraction inside this parenthesis. And see what happens. 3 drops, negative drops, 2 drops, parenthesis drops. What's inside the parenthesis? 0 minus 2. Well, that's minus 2. 0 plus or minus anything is that same number that you try to add or subtract. And that's what happens on the left. The symbols drop. See what happens on the right now. I need the PEMDAS for that. Do I have a parenthesis? I have a parenthesis, but there's nothing to do in there. So nothing. Exponents, nothing. Multiplication, I have a multiplication here. So this is what I'm going to do. And let's see what happens. 11 drops, and then you have plus 4 times the multiplication that we're doing, 1. Well, anything times 1 remains unchanged. So here is plus 4. If you want to see it, keep in mind that this one is positive, so you have positive times a positive gives you a positive, and then 4 times 1 gives you a 4. Okay, so we have new line here. Let's see what happens on the left. We need the new PEMDAS. Let's start with parentheses. I have a parenthesis, nothing to do, so not really. Exponents, no. Multiplication, yes. So I'm going to do the multiplication. Anything else that's not this multiplication drops, and in particular 3 will drop. Now I have negative 2 times negative 2. Negative times a negative is a positive. 2 times 2 is 4. Symbols drop. Let's see what happens on the right. I need the PEMDAS for that. Do I have parentheses? No. Exponent, no. Multiplications, no. Division, no. Addition, subtraction, yes. So I'm going to do addition, subtraction, and that's the only thing that there is there. And that's 11 plus 4. They're both positive, added and remain positive, and that is 15. Okay, let's see, new line. There's nothing to do really on the right because it's just a number. Here I can immediately see that, okay, it's an addition, but I want to get into the habit of using PEMDAS, so I'm gonna write the PEMDAS. Do I have parentheses on the right? No. Exponents, no. Multiplication, no. Division, no. Addition, subtraction, yes. And those are like terms. I can add them. So 3 plus 4 is 7. Greater than or equal to 15. Okay, this is what I found here. Now let's see what I expect to find. I expect to get a false statement. So I expect that this is false. But that is written, what's written here really means that. So this double arrow means implies. So what's written here really implies or means the following: 7 greater than 15 or 7 equal to 15. If any one of those is true, then the whole statement is true. Now let's see. Is 7 greater than 15? Well, if you look where 7 is and where 15 is, you'll see that 7 is to the left of 15. So what really is that 7 is less than 15. So this is false. Obviously you can see that even without the number line, but I put it that just in case you have any doubts. This one now, Is 7 equal to 15 true? Well, obviously not. 7 is less than 15, so this is false. Now what we got is that the two statements that are related by the or, they're both false. That means this is false, the greater than is false, the equal is false. When they're both false, I get false. Now you may say that, oh, is that a bad thing? No, it's not, because this is what I expected to find. I plugged in a number that was in the false area. 0 was in the false area. It would have been bad if what you found here was not false but was true. If you found something that's true, even though you plugged in a number from the false area, that means you have made a mistake. The same thing that when we plugged in a number from the true area, that number was -3, and if instead of having true we found false, that would have been bad. That means we have a mistake. And that concludes our confirming our solution based on our findings. Everything was found as expected, so our solution was confirmed. Now, before I move on, one may plug in -2. Okay, what if I plug in -2? What do I expect to find? Now notice that -2 is included here. There's no circle to exclude it, and my solution was really equal to -2 was allowed. So if I plug in -2, I expect to get a true statement. Oops. Now if it was excluded and I plugged it in, I would find a false statement. Okay, but if you plug in one number from the true area and one number from the false area and you get what you expect, it's all good. If you want to plug in two numbers from the true area, one -3 that's a little farther away from the endpoint and one exactly the endpoint, fine. Meaning if you want to plug in the endpoint and check whether you get a true or false statement, fine. But if you do one to the left of the endpoint, one number to the left of the endpoint, and one number to the right of the endpoint, that usually gives you that's good enough. Okay, summarizing, we plugged in two numbers, one from the true area, one from the false area, that was -3 and 0, and confirmed that the statements that we got was a true statement when the number was in the true area, and a false statement when the number was in the false area, and that gave us confirmation that our solution was correct.